Hi, Gopi. Can you hear me?
Hi, Sammy. This is Gopi.
Hi, how are you?
Doing fine, thank you. How about you?
Good, good.
So today is a special meeting or so?
Now we moved from Monday to Fridays going forward.
Okay. Got it.
Because Monday morning people are just getting to work and
Right. Sure.
uh,
Agreed.
we are not West Coast friendly.
Right. Okay. Sounds good.
Yeah, today agenda is going to be light.
Okay.
We were originally thinking of having a white paper review, but we are not able to get the white paper fully ready.
Okay. Sure. Yeah. Sounds good. You're going for the event next week, right?
Yes, I will.
Okay. Yeah. You mentioned about it in the email. You've been in Oregon since long time, right? Pretty much.
Yeah.
Okay. After Titanium days, he moved from DuPont to, right?
No, I always
Oh, you
lived
were
in
in
Oregon.
Oh, I see.
Yeah,
Okay. I'm mistaking.
yeah.
Because I know so many buyers and firmware folks, they were all quite a few of them were in DuPont. So I was kind of good, nice. Yeah, sometime back, a few weeks back, we were talking something and something, this one came, Kitty Tiano buyers and all those stuff, came into the discussion, right? It was interesting. So long time.
So are you going to be in there, Kobe?
No, so I don't know. I'm not sure, because
Okay.
I need to get the approvals
Okay.
and all those stuff. So,
Yeah, sure.
and then I have some face-to-face here also. So, not sure.
Okay.
I wish I can come. So, let us see.
Um, so looks like we don't have people. I don't know. The only thing I was planning to discuss is related to even if you the ICU,
Uh-huh.
IUE
Right.
metrics, if we define,
Uh-huh.
how is that going to be uh, utilized by the data center? Because are they going to publish
Yeah. Mm-hmm.
those data, or is going to be mostly going to be consumed internally by the data center and it's never comes out, right? That's the only thing I was thinking of having a
Right.
discussion,
And then also a few things came to my mind after the meeting.
right?
What are the software controls that you're going to design in place that way you can measure at any polling interval, and then also how it can integrate back through API services back into orchestration services like Kubernetes or whatever the case may be, or any data center application, vendor, software, right? So
Right,
those also needs to be kept in mind. And then, of
right,
course, once you have the measurement, then controls come into place also. What can I dial up and down or so? They are important also, right? So,
right. I think yes. What is the normal polling mechanism, or how often we want to capture the data, right?
yeah, right,
Right,
yeah. Because when we do the optimizations, like, looking at low-level micro architectural stuff, we
right,
collect data almost 25 milliseconds.
right,
But when you are doing at a different data center level, it may be different, maybe a minute
right,
or 2 minutes or whatever, everybody varies, right? So
right.
it's good to keep that perspective in mind also.
Hi, Deb.
Hello. Gopi, I don't think we've met. I'm Deb Bernstein from Intel.
Oh, hi. My name is Gopi, and I work in Federal in Washington, D.C. as a senior technologist, driving with Department of Defense and ARPA-E data center for 2030 and beyond. Yeah.
Oh, how exciting!
Yeah, right.
Just
Yeah.
to note, this call is recorded. So.
Yeah. Yeah, Virginia is the largest data center in the world.
It is, yes.
Yeah,
and there's a lot more that are in the queue to be built. So
yeah,
probably we'll keep that prize for the foreseeable future.
Right. Yeah. Whenever I drive, I see so many coming up. It's just unbelievable. Where are you located, by the way?
I'm in Massachusetts, so same time zone, but
okay.
a ways north of you.
Right. Yeah. Probably we must have met in some meetings. I don't know. I used to interface with Matt Adalata's team.
Oh, he's my boss.
Oh, really? Oh, okay. Then we must have crossed across. Because I used to work for Firebricks, under Steve Pulaski long back. So
Oh, funny. It's a small world.
Just to note, right, this is a call is being recorded by this one. So
yeah, right. Okay.
Make sure that you are aware of it.
Sure.
Yeah, we do get a notification of that when we join the calls.
Yeah.
Okay, we'll keep it to the content.
Right.
Okay. Okay, you're showing something. Yeah. Go ahead.
I think the sampling period you were asking, right? What we are really saying is currently there is multiple different ways people are measuring it. I think
okay.
12-month average is some people are recording, some people are recording monthly. Right?
Oh, okay.
So, but I think you are right. I think at the end of the day, what we want to recommend, right?
Yes. Yeah. Right. Definitely.
So, Deb, I think today we were originally thinking of having a white paper kind of ready for review. I think we didn't have a chance to complete that. The only question I was trying to see some feedback is even when we have IUE, I think this is what we were kind of referring in the IUE side. That is that.
Yeah.
Let me go there, right? So this is how we are kind of trending finally, right? It's IEE is total server power load by computational power load. And how do you want to say the total computational power is total server power minus thermal power and conservation power, conversion loss and ideal losses.
What is ideal losses?
Ideal losses is if you go back here, right? You have ideal, when system is running ideal, you are consuming power. It's wasted, right?
Yes.
So that we are accounting as a non-computational power. So basically like the computational power is from here to here, right?
But as an industry, do we not want to drive down the active idle?
That's what we have to drive, right? It's first we have to define it. Once we define and agree, then we have to go back and drive that as a mechanisms, right?
Can you go back to the previous? So, but you're subtracting out the idle losses here.
Yeah, from total power, the computational power is from total power minus ideal losses, any thermal and power conversion losses, right?
So will this metric what will this metric incentivize who to change? Maybe I'm just not.
So it will give a benefit for people try to reduce idle power, right? And also if you have a thermal, power conversion losses, it will try to reduce your PSU and other things.
Oh, wait a minute. Does this mean that we're subtracting the idle losses from the total server power?
Correct.
So then how does this metric incentivize people to reduce the idle loss?
So the computational, so if you want to get to 1, right? Here,
Oh, I didn't look at that little thing. Okay, let's see.
if
Gotcha.
both are equal, then we are getting 1.
Okay, now I understand. Thank you. Sorry it took me a
Right.
minute.
And we set thermal power that way. It can be fan or can be immersion cooling or anything
Yep.
that you want, right? So it comprehends everything there. Right?
Yep, that's a smart use of words.
So this is what we are really like want to say. There may be some additional work and other things needed, right? Because today in ideal losses, there are also thermal going on there, right? But for ideal thermal power, you can say that, right? And if you, so basically what we really want to go back here, right? We want to say from this to this is the IT equipment power, right? Or computational power. All the remaining thing is not computational power.
So you're basically nailing down to the useful work, then only
Right.
you capture the power which
Right.
is consumed for that useful work. Yeah.
Right. If you design it really good, then ideal thing you're going to reduce it to kind of 0, right? That's what we want to see.
Mhm.
And if you're able to reduce to 0 and you don't have any, if you make cooling efficient, then it makes you better, right? And thermal loss is going to be reduced. And if you make VRs or things very efficient, you're going to get the input output is like 99 some percentage, right?
But we may make this IUE load, 1. However, in the cloud infrastructure environment, you cannot, you can you can negate that, but it's okay. But if you want to still further reduce, you have to shut down the servers. So that means you pay a huge penalty. So I don't know how they will take it, I'm not sure, right?
Now, today maybe you have to shut down, but tomorrow you can figure out a very ideal, you can wake up very quickly, right?
Well, and there are also P states and C states.
Right.
Right, yeah,
that,
sure.
if folks are not enabling any of that, and if they start to enable it, this metric will get better theoretically, right?
Right.
So they don't need to go all the way to turning it off, at least in the beginning.
Yeah, you want to see ideal losses if you go back here, right? It's what you are saying is this has to be 0 all the way, right? Or
Right.
1% or something like that, rather than showing a bigger number here, right? Or in other words, what we are showing here is 15% bigger number, right, compared to other two, because in ideal cases, you're really operating much more. I mean, power thermal is going to be very low, right? So I think that is one. So then also, but we are saying the network side, we basically saying it DC network energy by how much really like getting used, right? And this is probably when you say total bytes moved, it still give energy per byte. I think what we are really want to say is this is the one we want to go after. How much the number, but I think there's no normalized number here, right? I think
Yeah.
we need to figure out how do we normalize it, right? And that one and the other one we really want to propose here is this is the 3 things we really like want to propose.
Water is effectiveness. Yeah. Okay.
Right. At least the work we have so far done and summarized it here, right? What we are trying to say.
Mm-hmm.
So yesterday I did put in the comments So you said no allowance for groundwater. Oh, that's the limitations.
Right.
I see. So I'll try to dig it up again. What the climate neutral data center pack did for water.
Mm-hmm.
It was interesting. I mean, the guy that was talking about it knew a ton more about this than I did, so that's why I.
What are you referring to brown water here? Can you?
Yeah, brown water is one. So you can think of what do you say? I'm trying to find a good wording here. You are able to recycle the water.
Mhm.
Then it is you are really like utilizing the water that is cooled by you, right? On site.
Right.
Offsite is
It goes to the
offsite.
cooling. Yeah. Go ahead. Go ahead. Yeah. Sorry.
Yeah, offsite maybe the things for your city is trying to reuse the thing. You're not wasting it, right?
So you're reclaiming the energy in a way, right?
Correct.
Okay. Rather than just putting onto the cooling tower and then evaporator and back, then go back and have an heat exchanger where you can convert to steam and use steam for something else, cooling, heating, whatever it is, right? Okay.
Correct. Because that's what people are using today.
Yeah,
To
right.
at least most definitely, we want to give a benefit for the people trying to use it.
Right. Yeah.
So I did put in the chat. I know it's not super readable. What they defined is potable water, fresh water, gray water. Gray is wastewater with low pollution level, no fecal matter, reuse potential in adherence with some ISO standard. And then black water, wastewater with significant pollution level, etc. And then they talk about seawater or brackish water. So they define that.
Yeah, but you may end up in treating all this water to make sure that it funnels through the piping and everything. That means you're spending energy somewhere else, right?
Well, so this person was saying that they have a data center that uses seawater, and they don't very, very light touch as far as processing of it.
Because you need to have all these pumps and everything which consume energy in a way. So you're offloading the power to somewhere else in a way, right?
Well, the data center is near the source of water. So, you know, he was just talking about all sorts of examples.
Sure, yeah.
I mean, he was, like I said, much more way ahead of us on this, I think. And he was able to cite a lot of examples. So,
yeah, I've seen some examples where some of the companies have located the data center close to the ocean, where you can draw the deep, ocean water, which is very cold, and they kind of all kinds of uniqueness in a way, right? So, but there's a penalty they pay. Pumping costs are the huge, right? Because you have to pump, right? So that consumes a lot of energy. So do you really benefit from it or not? Don't know, right? So yeah.
So, but if you look, he says that WUE limit, they said 0.4 liters per kilowatt hours times a climate score, a stress score, and then a water type. So we just talked through the water types, and that makes WE limit. Climate factor, they're taking into account the difference between cool and warm climates. Stress factors takes into account the stress, water stress at the location, and then water type we just talked through. So
I think, but we are probably agreeing here, right? I think the currently defined WE need to be updated to include some additional things.
Yeah, right. Yeah.
Right, but you didn't take that all into account in the proposed WUE.
Okay.
That's
Um,
my point. Like we might want to take into account the location temperature and the location water stress, and not just brown water, but all of these other kinds of water.
yeah, I agree. Yeah.
I mean, for the places like
Right.
in Iceland to Norway and other things,
Right.
yeah, it
right,
makes
right.
quite a bit, compelling equation. But for other geos, don't know, right? You need to do some analysis, measurements, and other things.
Yeah, I think we need to have a little more clarity on if we are going to use it. If it is null, we can say null, right? Nothing is there, right?
Right.
That way, the formula need to be a little more extensive. That way, it's clean and clear, right?
Sure. Yeah. Yeah.
Yeah,
Agree.
I will. Thank you. I will add some additional text to kind of comprehend that. Yeah. So those two are the main thing out of the work, right? What we are saying is we looked at a lot of different things. I think these 2 or 3 things is the main thing that we
Can
kind of.
I ask, so why did the networking thing bubble up to the top, Sammy?
Because in PUE, currently they don't define what is that like here, right? Kind of IUE. What we are really trying to say is PUEs today includes networking too, right? Total
Yeah.
energy, you don't care whether it goes to IT or it goes to network or anything, right? And given for IT, we are putting the IUE. The other portion of the IT is network, but network, if so, in other words, to say, right, if you have local data, you're not moving the data that much, then you're trying to giving people for not moving the data that much, right? If you're keep on moving the data, you're wasting a lot of energy there, right?
Well, I mean, you're attacking modern software architectures when you say you don't want them to move the data.
No, we don't want. They can move the data as long as the energy to move the data is low. That's all we are trying to say.
Because for some class of workloads, like Graph 500 workloads, right, which runs on clusters, anywhere from 16 node to 16,000 nodes, that means there's the internode communication, right?
Exactly.
Storage and network is involved. So it means if you don't supply enough power, there's no way you can move any data because the other processor is waiting for results computed from the other node, right?
Yeah,
so
I think
network is right?
Yeah, what I'm saying is as long as the energy to move is low, you want to give people who are trying to optimize that, right?
But we don't have any power controls for the network switches and everything, right? Compared to this process and everything, that means it's hard to say consume less less power, right? It becomes harder.
Well, and you have to know everybody else who's passing through the switch and their share of the energy. Usually your share is a small fraction, right? So actually understanding the energy that's associated with when I'm saying you, right, a software architect, right? So
yeah, that's where the problem here, even here, right? Unless people are publishing node level or rack level, you're not going to get the data published outside, right? What we are saying is we are providing as a what do you call through OCP, we are providing the infrastructure so that you can at least collect the data internally, right?
Measurement has to be done, no question about it.
So as long as you provide the measurement mechanism, then you can go back and say like, hey, how much they probably already doing it today, right? They can, as long as you can calculate and say like how much I'm getting, I'm spending energy per moving the byte, right? If that number goes low, then you can move all day long, no problem, right? If the number is high, if you're moving too much, then they really need to look and go and see optimize this area, right?
Does that mean by newer generation switches, or do they want to talk to all their software architects and get them to all change their?
So both, right? So you need to look at a better efficient switch for moving the data. And also you don't want to have too much overhead for the byte movement, right? If you have too much extra headers, it adds energy, right?
Well, but
It, yeah,
a typical software person, it's IP, right? I mean, like Internet Protocol, right? And the headers that are slammed on by all the different layers in that networking stack is just out of your control. But it gives you the capability to get from point A to point B with reliability, yada yada, right? So people aren't going to say, oh, I don't think they're not going to reinvent IP protocol or anything like that at this point. It's like,
Yeah, I think what we are saying, Dave, is two things. We really need to want to go towards performance-based metrics, right? If you go to performance-based metrics, so that today you're giving people who's trying to optimize it further, right, to reduce power consumption for ISO performance, then it will include what is the IT and how much the data you're moving, right? As long as performance, whatever the benchmark you use, includes the data movement too, right? Today, if you look at IUE or PUE, they don't care how much really are computing or what are you doing out of it, right? What they're saying is it really consumed by the IT, right? If it has no useful work, still, as long as you can claim PU is better.
yeah, no, I agree with that.
Right.
Yeah, I mean, you can throw this out there and see if anybody uses it. Let's go back to the IUE.
Right.
So the total computational power, how so this is something we're actively working on in the green grid, right? But in your mind, how do you think say somebody has a data center, rows and rows and rows of racks, right? All different generations and different DIMM configurations and some GPUs, etc. Right?
Right.
So how do they know the total computational power?
So there's multiple ways of looking, right? One is you can think of node level aggregating to the rack level, or you can.
But how do they know at the rack level?
So if you go to the rack, top of the rack, right, you're going to consume rack level power, right? And from there, you're going to have
that's the active. But what about the total? Right, the total computational power, I think you mean, is like what it could be.
No, what is currently consuming active?
That's active, but
Active,
what about
but load,
what
right?
about
if you put
what's the denominator? How do you know the denominator?
So for example, ideal, if you put ideal, right, both side, what is the ideal power? Or if you put a 50% load, what is total 50%?
How do you know the 50% load power?
So that is you have to compute. I mean, you have to calibrate to say like if I do a 50%, what is total power consumed here, and how much it's really going to IT, right?
Yeah, I understand the active.
Right.
You can monitor that.
Right.
But the total, the denominator. So we're going through this in the green grid right now, right? At the data center level, not at the rack level, but you can think about it. The data center is just lots and lots of racks, right? And we are, you know, I asked the owner of a data center, like, how are you going to know what you have? And he said, well, we would, put on our ear protection and we'd start to walk the data center. But we can only do it in half-hour increments because of the sound. But we would very slowly walk through, for every rack, kind of try to figure out what's in there. It might be a mix of,
Yeah,
Gen 3, Gen 4, it might be.
Yeah, that's what we discussed last time also. That is one area like this is all looks like a calculation values, not really like what is currently consumed. If you say data center is 50% load, does not mean all the systems in 50% load, right?
Yeah,
some
but
are 70, some are probably 30.
But I'm just saying that even at the rack level, right?
Right.
If you want to do it for every rack in the end in order to make progress.
Right.
Right. And I'm just trying to give you a sense of somebody on the ground. What does this mean to them? Right. So they'll kind of like eyeball it and say, well, kind of looks like we have some of this in there, some of that in there. Maybe we'll go try to verify that with Redfish, right? And then so therefore they have to look up someplace, right? So say that they have, 2 racks of GPUs, 2 motherboards filled with GPUs, 3 motherboards with Gen 3, 2 motherboards with Gen 2, and then a bunch of disks, right? A motherboard filled with disks. So they need to total up for that unique configuration, the denominator here. How are they going to find that at all the loads, right?
Right.
How are they going to find that?
Yeah, that's exactly the discussion we had Monday. It's difficult. We need to come up with a recommended numbers because like workload, right? There's not all the workloads are kind of equal, right? If you take a workload metrics for CPU versus GPU, may be totally different, right?
Yeah.
Yeah. Then now, when you're right, when we say I'm 50%, are we saying it's a GPUs 50% or
CPU, FPGA?
CPUs?
Yeah.
All right. What is 50%,
exactly.
right?
But what I'm saying to you is even within a rack, you can have that mixture.
Correct.
Yeah.
Right.
Right.
So, what we're doing in the green grid, I guess I'm not sure if I'm allowed to say that in this forum, but we are, let's just say we're approaching this problem from the data center level because in the end, right, that's the whole system that a government would try to regulate, let's say. So we are working on this problem, publishing, let's say, somebody could publish this information and you could, try to fit as close as possible for your rack to that.
Like, yeah, you can calculate based on the nameplate what the power is, and then you can, one second, let me finish. If you don't mind. That's one, you'll get an idea, theoretical one. But when you go back and measure at the, wall power for the whole rack, you get another, data point. But the problem will be if I have a server node with the 2-socket platform, I'll throw in 2 GPUs, 4 GPUs, 8, 16, etc. There is no way you can run all of them at the maximum, right? I can't run GPUs at the 1.6 gigahertz and also CPU at the max, gigahertz. So that means there is always a trade-off of the power, between both of them, right? So that means we cannot say I'm going to run at 50% load, 60% load, or 30% load. There's no way you can do any unless you do the actual measurements, right?
Yeah, but even today, people are calling I'm 30% or 40%, 50%, right? There should be some metrics that are using it, right? For this one, I will call out that is work needed to define what is the load means here. right?
Right.
You can say per system, you could probably have a load number, but does not necessarily mean a rack level or data center level. It's equally, we are saying that thing, right? There is work
Yeah.
probably needed to kind of say like,
Right.
hey,
Yeah.
how do you,
Sure.
what is the percentage you want to?
Right.
Yeah.
I'll give an example. When I used to deal with one customer without naming anything, they had 16,000 servers,
Right.
which are running 95%. Databases were running on that 90%, serving the whole e-commerce.
Right.
Whereas if we take the other side of it,
Right.
other, general compute, there's only 35 to 50%.
Right.
So it varies based on what you're really running, right? So I think that is an important aspect, that needs to be factored, right?
So you're
Right.
talking like the load, like the utilization.
Right.
When you get
Utilization, yeah.
So when you say utilization, does that utilization is reported by the operating system or some of
They
that?
they have measurements in place, right, where they measure, completely, from every angle, then they composite index, and then they go back and look at, translate back into how many web pages I served per kilowatt hour, and they look at the
Yes.
pattern over a day, every hourly basis, and they average it out, and their database are consuming like roughly 92 to 95% of the time, all the time, around the clock.
Yeah, databases are
Yeah, pretty intense,
can,
right?
yeah, they veer towards the HPC these days.
Right.
As
Yeah,
far as
they are like, yeah, sorry, go ahead. Yeah.
no, I think we're in complete agreement. I would just throw out from a regulatory point of view, they use CERT, right? The spec CERT to for and the load from those CERT worklets, and Gen 3 for that is coming in by like 2025, will include some AI GPUs,
Yeah.
etc. So that is, that is a path you could direct people towards. My stance is for if PUE is easy, right? So people have worked on it and improved it, right? A lot of these other things are hard. Regulation will force it, which is why we're paying attention to what's going on in the EU and how that's all happening. And they are very CERT focused for things like the load.
Yeah, I think what we want to do is we need to be upfront. It's not already fully defined and baked and agreed. Right. It's still a work in progress. We are kind of peeling the onion to see where we can make some improvement, right?
Yeah. Yeah. No. Awesome.
Great, thank you. For sharing. Where are the slides? Just I was trying to see. So
there is no common area today, right? I basically uploaded to the what do you call presentation portal in the OCP.
Okay.
And I think when we present, they will publish it outside, right?
Okay.
But internally, I can send you the thing internally.
Yeah, can you send it? Thank you.
I just wanted to say, OCP right now there's a wiki, and you could share it through the wiki, but I don't know if it's worth your efforts, Sammy, because OCP now is moving to GitHub.
Yeah.
But you should in short order be able to publish, and have multiple authors updating things at OCP. We do that with that other work group, right? Through the wiki, you can get to our running minutes through the wiki. You can get to our running white paper. So you should get there over time too.
Yeah, I need to sit down and figure out that complete logistics there, how to do that. Yeah.
Oh, I spent a lot of time. I'm so like, oh no, I just figured out this wiki thing, and now you're telling me it's GitHub, but that's nice.
No problem. You can send me when you get a chance, Sammy. I'll look at it and
Okay.
kind of provide input. Thank you. I
Okay.
appreciate it. Yeah.
Okay.
All right. Well,
Thank
good
you,
luck
Tim.
with the presentation. Bye.
Yeah.
Thank you.
Yeah. Well, thank you for the input, and we will meet next Friday before we go to the OCP.
All right.
Okay.
Sounds good.
Thank you.
All right. Have a good day.
Bye.
Bye.